The day has finally arrived to assemble my new battery pack. Since the last video, a few things have occurred. I've been over to Fogstar to collect my cells, which I'll be using in this build. I'll include details of what I bought in a follow-up video. A major milestone was reached as I've had a registered electrician check the installation of the inverter, all this stuff behind me. He was happy to connect it to the grid and sign it all off. So I'm just waiting for the NIC EIC paperwork and also the building control notices to come through. And once I've got those, I can submit those to the DNO for final approval. These rules and certificates are only applicable to the UK market, but I suspect most other countries will have very similar sort of steps to go through when connecting the equipment to the grid. As you can see behind me, I've also bolted some brackets to the wall to affix the new battery box to. Although for now, I'm actually going to build a battery box on the bench. It's going to make it much easier to fault find and also make these YouTube videos. I've also had some bad news. This red socket here for the emergency power supply can't be used as it's currently fitted. This is an optional feature that's supported by the inverter, but I've had to disable it for now. To meet the UK electricity regulations, I would need to add RCD protection and also an earth rod into the ground to make it compliant. This might be something I do in the future, but as I've not experienced a power outage for about 10 years now, I'm not really too worried at the moment. So without further delay, let's crack on with this battery build. So first steps, there's a bit of a sharp edge on here, so I'll put some of this protection strip on. So if you remember back to my original diagram for the design of this, I'm basically filling the box full of insulation. I might have to leave the lid off, it depends on what the sort of temperatures are inside, but this is a 10mm XPS insulation, which is based on polystyrene. It's only 10mm thick, but it's very dense and a bit scratchy. So I've cut these to size, so they should just squeeze in, but hopefully they don't make too much squeaky noises. As you can tell, I've pre-cut all these to the size. So if you remember from the CAD drawings, we've now got a big metal frame that goes inside this. Oh! And here it is. So that somehow needs to go inside here. Is it too wide? Yes, it is. It's going to be a tight, snug fit by the looks of it. So I need to undo these mounting brackets. I was hoping to install all this in one go, so I'm now thinking this may not actually fit at all. Have I designed something that's impossible to build? Wouldn't be the first time. As I mentioned right at the outset, this whole thing is way overkill for what I actually need. That's it. Just need to get it over the front lip. So the way this was designed to work, we've got some plastic insulation sheets. So these are actually polypropylene, which go either side, and another sheet squeezes in the bottom. I think that one's probably going to need to be trimmed down. But for now, they can tuck under the base, and then we can drop the set in to look at the gaps and tolerances. It's pretty tight. So against each end panel there is a fiberglass sheet that just isolates it against the metal end plate, and a piece of EVA foam which squashes against the end panel, locking that in place. So given how difficult a job I've had to put all this together so far, I think I probably need to lock those bolts together, because that is pretty much millimetre perfect. And between each cell we've got a foam sheet. Obviously going positive, negative, positive, negative. Right, the whole idea of this is that the last battery, or the last cell, isn't actually going to fit in there. So this compression plate is unscrewed, and then fingers crossed that will slide in. Oof, it's still a little bit tight. Okay, here's a quick status update. We've got the lovely battery basket with insulation, the 16 cells, along with the retention bars or retaining bars, and those have all been tightened up. It's actually compressed everything by about 10 millimeters, but obviously most of that's going to be the foam squashing together. So the idea of this is that we've got the positive terminal down here, and then it goes zigzags all the way up here. Most negative is this end. Originally, I was putting a cable containment tray down the middle, and that's where the negative cable would have run down. This isn't the best way of arranging batteries. Ideally, you'd have an 8 and an 8 with next to each other, but obviously that's more of a sort of rack mount arrangement. It just helps you reduce the amount of cable runs. So what I've got now, basically I'm going to end up with the negative terminal right the way down here and a cable running all the way back. I've decided to wrap it into this conduit just so I can run that down the outside and keep everything hopefully isolated. There's two cables here, the smaller one's for running the BMS and sort of additional equipment, and then the main black negative cable as well. I'm going to give everything a quick blast of contact cleaner. I don't know how long these cells have been sitting out. So again, this is positive to negative, positive to negative, positive, negative, positive, negative, and it just goes all the way up and down to zigzag around. Obviously I need to add on all the BMS connections in here, but for now I'm actually just going to lightly put the screws on, or the bolts, nuts should I say. So I'm now going to torque each one of these down to 4 Newton meters. One's already there. Oh, this one's quite loose. Right, the moment of truth, using what could possibly be the world's oldest multimeter. Now, ooh, can I reach there? No. Get a voltage measurement. Now, I can't actually see what it says on that screen. Hopefully you can. Oh, reading it upside down. 52.0. Great. So this multimeter I had when I started doing electronics at college, and that was a very long time ago. So I think this meter's at least 20 years old. Still works. I do have better meters, but this is one I just keep in the garage. The original design of this battery enclosure included a cable tray that ran down the middle. Now originally that was just designed for running the cables up and down, so the negative and probably all the BMS cables. But at the same time, I also hoped that I'd have finished my all-in-one DIYBMS controller and balancing unit. That's not been completed at all. So instead, I've decided to use the existing DIYBMS modules and deploy them on the tray instead. So that's what that looks like. So this is what 16 modules look like, the DIYBMS. Now the observant of you might be looking at this and thinking, hang on, my modules don't have these green connectors on them. And you'd be right. You can see that it's currently version 4.5. Now I haven't actually released this version, but I may do soon. But the key thing is that it's got a different connector instead of those JST connectors. As much as they're useful and they're very cheap to buy, I absolutely hate those JST connectors. They're really fiddly to actually make yourself. So I've swapped over to these pluggable terminal blocks, which are good, but they're a little bit bulky. So the next thing we need to do is to connect all these modules up to the battery terminals. Right, now I'm going to secure this cable tray in. We do that with these plastic blocks. These are just 3D printed, and they should screw into some pre-tapped terminals in the end plate. Finally, the moment of truth. We can now plug in these BMS modules. Hopefully we get a flashing light, which we do. Now, given that this battery box should have had a insulating lid over it, I may not actually use that in the end. It depends on what sort of temperatures these modules get up to. I'm hoping that I won't need much balancing. But again, that's a bit of an unknown at the moment. Certainly over winter, I may need to leave the lid in here to make sure the temperature stays up. So that's all the cells now installed, and also all the DIYBMS modules connected to each of them. They're all torqued down, everything's ready to go, so that's great. Let's concentrate now on the front panel where all the controls are for this unit. Up here we've basically got fuses for the main negative and positive connections to the battery. There's also a shunt trip there. I'll explain how that works in the future. And also a fuse for the driving the ancillaries, so things like the DIYBMS, the current shunt, and all that sort of stuff will be going through that fuse there. These are all DC rated units. You've got the main positive and negative terminals for a connection into the inverter. These are rated for 250 amps, although the inverter I've got only actually needs 60 amps max. These are 80 amp fuses. There's connection for the CAN bus to the inverter as well. These two are currently unused. I've got a pre-charge circuit that will charge up the capacitors in the inverter to make it easier to switch these on without tripping. A red emergency push button for shutting things down, and currently these black buttons and the green button don't actually work, but I've left those in just as a future requirement. So this is the reverse of the front panel. Again, we've got the fuses, or the circuit breakers over here. This isn't actually all wired up yet, so that's the next job. The DIYBMS controller, the connections for the CAN bus and the RS485, which runs down to the current shunt. I didn't intend to put the current shunt inside the battery enclosure to start with, but when I started building it, it actually made more sense, so I basically just bolted a DIN rail onto the front panel to make that work. We've got the back of the RJ45 connectors here, and the various buttons which are not fully wired up. These are the heavy duty terminals, so as I mentioned, these are 250 amps each, and I think they're basically just lumps of copper with some sort of coating on them. So now I'm going to continue and get the rest of this all connected up. So I know this looks like an absolute spaghetti mess of cables, but fundamentally it's all now wired up. We've got the mains, well I say mains, the main battery terminals in. The negative's not connected at the moment, so I'll sort that out after. This is a pre-charge resistor, and I'll show the circuit diagram for all this lot soon. And also a step-down voltage regulator. So this allows up to 85 volts and it drops it down to 12 volts. And then there's also a little 12 volt to 5 volt regulator for the DIYBMS. I'm also running the current shunt off 12 volt, although technically this can actually run off the battery voltage, so that's suitable for that as well. And then we've basically got a loop between the incoming breaker, positive, into the current shunt, and then back out to the terminal, going over to the inverter. The negatives there, unfortunately I had to do quite a sharp loop to make that work, but it's quite soft silicon cable. This is all 25mm square cable, by the way, so suitable for about 150 amps, even though I only really need 60. Pop some heat shrink around that terminal there as well, just to keep things nice and tidy. So we're almost getting ready to switch it on and give it a whirl. It's worth pointing out, actually, I'm actually using Wago connectors here. So they're not officially rated for DC applications, but for the very low voltages and currents, I'm actually using them here. This will be pulling for less than half an amp on these sort of things, so that'll be perfectly alright for that. So the moment of truth. Everything's now connected up. Is this going to work? That's the question, I suppose. Well, let's just go for it. We've got power. Well, that's all looking really positive. So it looks like the comms to the BMS is working okay, and also the current shunt as well. We can tap the screen, make it move forward and back. So I've not got any temperature sensors fitted at the minute, which is okay. And it's saying the lowest cell voltage is 3.62 and the highest is 3.98. And obviously no current or anything like that, so that's looking really good. Now the other thing we need to check is the voltage on the output. So that should be 0, or it's near enough at the moment. So there should be no output at the minute, which is what that's telling me. So we've got a pre-charge button, so if I press that, we should get the full voltage on the output, which we do. There's a few mismatches at the minute between the voltages. Nothing's been calibrated, so I need to take that away and have a look at what that is. Yeah, 52.3 that's saying, and the BMS is saying 52.5, so we'll see where that goes. And then if I switch this main breaker on, again we should just get the consistent voltage there. Recharge won't do anything at that point. Fantastic. And if we turn the negative off, yeah, we lose it, and the positive. Great. I've dimmed the lights a bit just so you can see the little LEDs on the DIYBMS modules. As you can see, the data moving between them. Get the little LED flash. Almost looks a bit runway-like. So I mentioned about the temperature sensors. So what I've done is taken the, I don't think that's in focus or not, but it's very small. You can snap off the temperature sensor off the module PCB, solder a few wires onto it, and that's what I've done here with the JST connector on the end of it. And then I've just wrapped it in a bit of heat shrink, and I think I'm just going to use double-sided sticky tape to attach those to the cell modules. So, moment of truth. Let's connect this up to the inverter and see how everything looks. I'll just check there's no voltage on the inverter currently. Nope. There's no voltages here. Nope. So there shouldn't be any risk to me connecting these up. These are M6 bolts with a spring washer on them. Can't be too careful. And we also need to plug in the BMS. That's a CAN bus connection. So I'm actually using DIYBMS here to emulate, run that a different way, to emulate a Pylon Tech battery. Right, the moment of truth. So we should switch on the negative, hit the pre-charge button. In fact, if I put my voltmeter on this, I might be able to stay there. hit the pre-charge, charges up the capacitors, so you can see the voltage on that slowly rising until it gets to the full 52 volts, and then I should be able to turn this on, and that's great. No smoke, no steam. All good. The DC is now on. I'll switch the AC on, and we've got power, which is fantastic. It's got a little graph on here with regards to the solar input and the grid usage and what the house is using. The solar input's actually incorrect at the moment, so the CT clamp's in the wrong place at the moment, but that's fine. The question is, will it start pulling from the battery? So it's going to this standby mode now. So if we look at the settings on here, we can see battery voltage 52.5 volts, charge current is 0, discharge current 0.2, state of charge is 99%. So that's actually just the DIYBMS current monitor reporting that. So at the minute it's not charging or discharging, so I need to go away and have a look what that means.
A few minutes later.
So after a quick bit of research, I found out what the problem was. Because I hadn't plugged in a temperature sensor into one of the modules, the code in the DIYBMS was clever enough to not let the inverter discharge or charge it while that was going on. So I've plugged the temperature sensor in, and as you can see from the screen, I'm now pulling 0 from the grid, even though it's dark outside, and the battery is now supplying 550 watts. So you can see the battery voltage 52.1, it's just pulling just over 11 amps, and state of charge is 99%. I know that's not valid at the moment, the batteries are probably only about 25% charge, but the BMS hasn't learned yet. You can see it's also reporting correctly the battery temperature, 14 degrees C. Brilliant. Well, it's the next day, and amazingly, the sun's come out. So with all that lovely sunshine, I'm now pushing 1.7 kilowatts into the batteries, and so far, all working well.